Okay, so maybe we can try to get started here with the NumPy stuff, and yeah. So I guess the projector is maybe not quite as nice as it is in the other room, but if you have a look at the course page, you can see here where we're at. In lesson 5, we haven't added the link yet to go to this data analysis with NumPy stuff, but if you click down there in the NumPy lesson, you can see basically what we're going to cover, and it's going to be more or less the same way that we've been doing things otherwise in the course, and that is that we're going to be using the Jupyter Lab. So if you click, for instance, on this exploring data using NumPy, you can go ahead and launch either Binder or the CSC notebook to have a look at this, the lesson materials for today, and that's what I've got opened up over here is the Jupyter Lab. And since we're in lesson 5, it's notebooks L5, and the thing that's different here today is that you can see things are divided between NumPy and Pandas. So if you go in, once your Binder session comes to life, if you go into the notebooks L5, we're going to be in the NumPy directory, and we're going to start with this first file on exploring data using NumPy. Otherwise, format's more or less the same. You can certainly feel free to interrupt if you have questions and things like that. And we'll see. I don't know how much time it'll take us to go through this stuff, but I'd be happy to sort of expand on things along the way if there's an interest in that. And if you have problems, if things aren't working, Lotta's hanging out in the back of the room, and you can also get her help if Binder doesn't want to open or whatever. So yeah, the focus for this week is basically to start into doing some data analysis. So both us and the other group are going to be doing more or less the same kind of thing, and that means we're going to be reading in files for the first time. So we've been just doing stuff in Pandas so far, in Python so far with writing functions, writing for loops, and if we had to have any kind of data that we were dealing with, it was usually like a list of things that we would type in or whatever. Now we're going to start actually reading data out of files, and this maybe starts to get a little bit more interesting for you, because now you start to get some of the benefits of doing things with Python, in that we can process data quite quickly. So for us, we're going to be working with NumPy, and there's, as Henka mentioned in the introductory stuff, there's a couple reasons that we want to work with NumPy. The quantitative geology part of the course does involve solving equations, and that's something that is easily done using NumPy. In fact, it's much better to use NumPy than Pandas for that kind of thing. So if we wanted, for instance, to find a range of values of x and then calculate the sign of x, it's easier to do that with NumPy than with Pandas. So that's the main reason. Last year we tried doing Pandas with everybody and then doing NumPy in the second half of the course, and it was sort of a disaster. So we're going to try to avoid that this year. So there's links on here, for instance, to the NumPy webpage if you want to go and read some documentation that may not be very interesting. But it does describe a little bit of what NumPy is designed to do, and that is mainly to deal with numerical calculations in Python and to do that efficiently. And we're going to sort of encounter some of the main pieces of NumPy in the lesson today. And I can sort of make a point to explain how they're different than some of the other things we've seen so far. But yeah, you can even, if you want, we did keep a link to the old materials of how to do reading data in the Pythonic way. I don't know if the link actually works, but I think the link from the web course page may. And that's the even more kind of low-level way to read data files in that is, well, it involves a little bit more processing to get to working with your data. So anyway, if we want to get started here, as noted, preparation is the key to success. So we need to kind of see where we're working. And if you run the thing in this first cell here. It's going to list the files that are in the working directory. If you see things like 1, exploring your data using NumPy, 2, processing data with NumPy, then you're good to go. That means we're in the right working directory. If you see something else, you may need to change into a different directory, and we covered this last week a little bit with changing directories when we were talking about reading in script files and things like that for functions. You can use the %cd command if you need to change directories, and if you're really stuck, you can get Lotta's attention, and maybe she can give you a hand with changing directories. Essentially, you want to end up in this directory L5 NumPy where we're working now. Now, first thing we're going to do is jump right into reading a file with NumPy, and there are actually a couple different ways in which you can read files in NumPy. Some are a bit easier to work with than others. We're going to work with the generic way to read files, which is slightly, maybe a tiny bit more difficult to work with than one of the other options, but it's much more flexible for complex data files. So, first thing we need to do though is bring in NumPy, and we're going to do that with an import statement, just like we would with any other module. So we'll import NumPy as np. And of course that's just because we're going to be typing np dot something quite often, and it's just easier to type the numpy dot whatever. Not a super long name for the module, but we'll bring it in, and then we're going to define a file path that we're going to call fp. So this is just the location to where our data file is that we're going to read in, and in this case it is one level higher up in the file structure, so like it's in the L5 directory rather than the NumPy directory where we're working. And so we're going to have fp equals, and then quotation marks, dot slash, and the file name is kumpula. And actually, if you hit tab, once you start typing in the kumpula with a capital K, it should auto-complete the file name. One of those nice little things in Jupyter notebooks. So if you don't have the dot slash or something like that there, or if you don't have it in quotation marks, you might not get the autocomplete to work. But we'll define the file path like that as a variable called fp, and now we can read it in now that we know where the data file is. And we're going to say that our data that we're going to read in we'll just call data, and this is going to be np.gen from text, txt. So sort of a weird name for this function, but it's just a general reader for information from a text file, so gen from text. And we're just going to read this file in and assign its data to a variable called data. So if you shift enter on that one, you won't see any output because all we've done is define a variable. So if we want to see what's in there, we have to do print. And at that point, you should see something. It might not be what you want to see, but you should see something. So, and yeah, if you're having trouble, let us know. So what do we see? Well, we see a bunch of nans, and that's not what we should expect to see necessarily in our data file. Nan stands for not a number in basically in Python and many other programming languages. So it means the information that was read in to NumPy was intended to be a number, but what NumPy got was something that it didn't understand to be a number. So that brings us to one of the first things that we should do even before you start trying to read the data file in, and that is to have a look at this file that we're working with and see what kind of data do we have in the file. If we just try to read it in, NumPy generally will expect that the first thing it will encounter is numbers, and it will start then filling in this data variable with numbers. Since it's got nan here, it means it encountered something other than numbers when it first tried to read the data. So let's go one level up here. If you're following along, you go to the L5 directory, And in here there's this file, Kumpula June 2016. And if you right click on that, you can just click open, and we'll just take a look in the text editor in Jupyter Lab at what we have. So, is everybody able to open this file? Yeah? So you can see that, right away, here's part of the problem. We've got 8 lines at the start of the file, or 7 lines that have some metadata, information about this data file that doesn't actually pertain to the data we want to work with. And if we're going to read this into NumPy to start working with it in Python, we need to tell it to skip over this header information, the information at the start of the file that's basically unnecessary. We also have here on line 9 some text, and you can probably guess from having worked with files like this perhaps in the past that these would be the headings for each of the columns of the numbers that are listed beneath. So year MODA might not mean much to you, but it's, in this case, indicating the year, the first 2 letters of month, and the first 2 letters of day. So this is a date here in 4 numbers for the year, 2 numbers for the month, 2 numbers for the day. Just a short form to write out year, month, day together. Then we've got some temperature values, maximum temperature and minimum temperature for each one of these days. And in this case, we're told that this information comes from here in Kumpula from 2016. So you have a picture of what's going on here, that we have a data file with some stuff we need to skip over reading if we're going to load it into NumPy. Yeah? So hopefully you saw something just like this here. So we know we need to skip the header at the start, or at least I'm telling you that you need to skip the header at the start. We also saw something here that I didn't make a point of, but the values are separated here by commas. Different data files will have different characters that separate the values. Commas are very common, but you can have semicolons, you can have spaces, you can have tabs. And oftentimes when you read that data in, you need to tell the reader or the file reader what it is that's separating things that are different columns of data, because it might just read this in as one single string, and then you wouldn't necessarily get what you expect, which is to have some column of years or dates, temperatures, and temperature min and max. So we can deal with this by telling NumPy, when we loaded in this thing called a delimiter, the thing it's separating the values in the file. So let's try again. We can start here by saying we're going to read in data. Data equals. We'll use the same file reader that we did before. So this is the np.gen from text. And the file that we're going to read is the first thing that we should give. So this is fp, because that was where we list the file path before. But now we're going to give some extra information. And in this case, we're going to say skip header. NumPy doesn't know how long the header is. It just is, it knows there's a file there, but it doesn't know how long the header is. So we need to say, how many lines do you want to skip? And in this case, we're going to skip the first 9 lines, because that will give us the first 7 that are commented out, the 1 blank line, and then also that line that has the names of the different columns. We want to skip reading that in to NumPy, because we want NumPy to only deal with the numbers in this data file. So we're going to skip those 9 lines, and we're going to tell it that the delimiter in this case is a comma. So delimiter equals, and then the character that is the delimiter in this case is a comma. If you had something like spaces, there are other ways to indicate that, and tabs. When we come to dealing with those types of data files, we'll give you some information about how to handle that. Because sometimes, like, one of the nastier cases to deal with is if you have different numbers of spaces between the columns. That's kind of, it's not impossible, but it's a little bit tricky, because it's not a single space. You have to tell it, like, there could be any number of spaces. So anytime you encounter one, just go until you encounter something that's not a space. So there's ways to deal with this stuff. And if you are a savvy person on Google, you can find solutions to pretty much everything when it comes to dealing with NumPy. They're not always nice, but you can find them. So if we try again, hopefully you run this and you don't get any errors. And if we print out data, do we see something a little bit better? I guess it depends on your perspective of what is better, but this looks more like data. And so now we can see something that looks a bit more like structures we've seen before, things that kind of look like lists. For instance, here you can see values that are enclosed in square brackets. And each one of these lines has a set of 4 values, and then you can even see that there's an outer bracket that's wrapping all of this. So we have this big block of numbers that's essentially a 2-dimensional data structure. Does that make any sense when I say something like that? There's both rows and columns here, so it's a 2-dimensional thing in which we're storing data. We refer to it by one variable name, but it refers to this whole kind of, in some ways it's like a spreadsheet of different values. There's columns and rows of the data that we have here. So what we've done is we've read in this data, and when you read things into NumPy, the default is that it will store them in what's called a NumPy ND array, which stands for n-dimensional array. In this case, we have 2 dimensions, so there's both a number of rows and number of columns. You can have 3-dimensional arrays and things like that. It gets kind of complicated to work with, so it's not really encouraged, but 2D arrays are quite common because they're a lot like a spreadsheet that people are familiar with working with. And these ND arrays are a different data type than we've encountered before, and so we can check out a little bit about the information that we have here. There is a note on the lesson materials if you're interested. Sometimes you're working with really big data files. It's not that nice to open them up like in JupyterLab. If you've got a 5 gigabyte data file that you want to load, opening it directly in JupyterLab to look at what the top 10 lines say in terms of what you should do with the header is not very efficient. So there are some other tools to deal with this. And for instance, if we're in JupyterLab, you can open up a terminal. You don't necessarily need to do this. I'll just show you for the sake of demonstration. But in here, if I go into our notebooks L5 directory, I can see here our Kumpula June 2016 with metadata file. If I wanted to see what the top of this file looks like, there's a very efficient tool in the command line environment in like the terminal here in JupyterLab, where I can type head and then the name of the file. And if I run this, what it does is it just returns the top 10 lines of that file. If the file is 10 gigabytes, it still very quickly just takes off the top 10 lines and shows that to you. So you don't have to open the entire file to look at, for instance, what the top 10 lines look like. Here you see we've got most of this. I guess you can't see the mouse cursor so well, but you've got the header, and then there's a little bit of data that you can see beneath it. Maybe you want to see a bit more. You can do things like head and then -n to specify the number of lines you want to see. So let's say we want to see 20 lines just to make sure that there's nothing weird with the data after the first few lines. You can do head -n20, and then that will return the top 20 lines, at which point you get a pretty good picture of what the structure of the data looks like in the file, and you can then start thinking about how to load it in. Sort of an aside, but just in case you go on to start working with bigger data files. The command for doing this.
Yeah, going to the directory and then you do.
Yeah, so it's not very visible, but it's called head. HEAD. Okay. So like the head of your body. And it will take the head of the file, the top of the file. There's also something called tail that will take the end of the file if you're.
So you write the head and then the file name.
And then the file name, yeah.
Okay.
Yep. And for instance, if you were concerned that sometimes different data formats, they'll put weird stuff at the end of the data file. If you want to know whether there's something weird at the end, you can do tail and then the file name as well. And if you do that, that will show you the last 10 lines of the file by default. If you give a -n, it will show you the last n lines of the file. So tail is useful just to make sure that there's not like some junk at the bottom of the file. One sort of recent example I dealt with was a data file with a bunch of information about volcanoes. It was like a big volcano database file, and the last like 50 or more lines were references for things that were in the file, like references for publications where the information had come from. So everything looks like a nice table until you hit this reference thing, and then the data loader was giving problems, and eventually we went and just found at the end of the file there's a bunch of stuff we want to skip over.
Yeah, I want to still ask the head command. How did you add take the 20 lines? It's like head underscore.
So it's head and then -n. So head, I guess this is, I don't know if I can make this bigger in the terminal. There's probably some way to do it. I think I'm already kind of zoomed in a bit in the web browser, so I don't know if I can make this a lot easier to read. But it's, head -n and then some number. So -n20, for instance, and then the file name after that. So it's just the flag for the number of lines you want to get out of there. And I think if you even give it something like, this file only has, I think, I don't know, not so many lines. If you give it, 20,000, it will only give you till the end of the file. So there's no problem with giving it more than the length of the file. I don't know why you would want to head 20,000 lines off the file, but you can. So. And you can see some examples also on the course page about using head. It's helpful if you're dealing with big data files. So, speaking of dealing with data files, let's do some of that. First off, let's take a look at what kind of data we've read in, and we can go back to using something somewhat familiar here. If you scroll down to the section on exploring our data set, let's see what kind of data is in our variable called data. And we'll do that by using the type function. You might remember that one from a while back. And with type, we can run this cell, and we see its type is numpy.nd array. So I mentioned that when you read things into NumPy, it creates or stores them in this nd array, and sure enough, that's what we see. If you're wondering what the difference is between, for instance, an nd array and a Python list, one of the restrictions for an nd array is that it should only have one kind of data. Python lists could contain basically, strings, numbers, other lists. NumPy arrays could go in a Python list. They can kind of be a generic container for anything. A NumPy array expects to only have one kind of data in the array. And that does put some restrictions on things like when you try to read in the names of the headers for the different columns, right? Like this year moda, and we've tried to read that and then also read the numbers. We have a problem in NumPy that it doesn't want to be reading both of those things. So that tells us that our structured data is an ND array. Well, what about the data itself that's stored in this array? We can see that if we print out data.dtype. So that stands for data type. And that will tell us the kind of data that is stored within this NumPy array called data. And so this is one of the attributes, if we want to talk the talk, this is one of the attributes about the data or an ND array, is that it knows what kind of data is contained. And in this case, it's a float with 64-bit precision. So it's sort of high precision floating point number. So nothing really shocking to this point. NumPy arrays also know things about how big they are, so we can check and see how big this data file is that we've loaded, and we can do that if we print out data dot shape. So this will tell us the sort of dimensions, the geometry of the information that's been read in. So when the data is loaded, the shape is stored, and in this case we see we have 30 rows and 4 columns. 4 columns seems to be consistent with what we saw in the data file when we looked at it in the text editor. 30 rows looks about right. In this case, we've got daily temperatures for June. There's 30 days in June, so everything seems to be checking out. So we can now move on to maybe manipulating the data a bit. Taking our first steps toward kind of doing some data processing. And just to remind us before we get started of what we're working with, you can print out data here. It might be useful just to refer back to what the original data looks like, because we're going to now chop it up a little bit using something called index slicing. And it might sound kind of weird, but essentially we're going to take out certain rows or certain columns from our data using the index value of the data that we have in this structure. So for instance, we can take a look at the value that is in index 2, 0. So this is going to give us the value at row 2 in the first column. You remember that index values start at 0. So actually this is going to give us the value at row 3 in index in the first column. So there's a little typo here. We'll fix that. This is actually row 3. So when we print that out, okay, right. Maybe I want to include the data in here. So if we print out the value of data at index 2, 0, then we get something useful. And that is this number here, 2016-06-03. And if you scroll up here, you see that in the third row, in the first column, it's 2.0160603 times 10 to the 7, which is the same thing as what we get back. Okay, it's using scientific notation because NumPy likes to do that, but we get the same number that we expect to see here when we access data at one location. Is this somewhat clear at this point?
Column 1 or
it should be column, well, yeah, that's right, yeah. Row 3, column 1, yeah. Yeah, and the index is 2 and index 0, that's right, yeah. It's easy to get these things mixed up, which is why we sort of try to make a point of really emphasizing it, because you see that even we mess it up when we're writing documentation. So, but I guess this is kind of clear. We have because we have a two-dimensional structure, we have 2 index values. The first index refers to what row are we looking for. The second is what column are we looking at. And in this case, when we look at row 3, column 1, or index 2, index 0, we get back the value here. So I know the index values and index stuff is a bit confusing based on previous experience with the course. Is this, you get it so far here, yeah? Or not really? Yeah.
I'm getting an error message.
Okay.
It's called like NumPy anti-array, the anti-array object is not callable.
Did you use parentheses instead of square brackets?
Yeah.
Yeah. So it will try to, if you use parentheses, it thinks you're trying to call a function. So. Yeah.
So when you put 2, it's gone to 3 because the first line is 0. When you put 0, it gives you the first one, so do the columns not get allocated as 0 straight away?
No, I mean, it's the same, it's consistent, like that, in this case, if we did let's say we wanted to print out instead 0, 0, that will give us the first row, first column. The value in the first row in the first column. And then if you want to do the third row, then that's where you would go to like index 2. And if we wanted to go to the second column, it's always going to be whatever the index value is plus 1. So second column, in this case 2, 1 should give us third row, second column. So third row, second column should be 6.84 something and 68.4, yeah. So, and again, you'll get to practice with this a bit in the exercise. So, yeah, that's good. It's useful. It's frustrating though to have this everything be off by 1. So, are there other questions? Okay. If not, let's continue. And so we can print out a single value by giving 2 indices, 2 index values, 2 and 1 in this case as it's been modified here. But we can also get selections or ranges of values out of one of the indices by using this colon character. So if we wanted to get, for instance, the first 5 rows for column 1, and I've called it column 0 here, column 1. We can get the first 5 rows by doing print data, again square brackets. And here, what we're going to do is go from 0 to 5. We're listing a range here, and you do that with the colon character, so it's going to take things starting at index 0 and going up to, but not including index 5. So the last value that's listed there is not included in the range of values that get taken out. So that means we'll get the values at index 0, 1, 2, 3, and 4. So the first 5 rows for column 1. And if you print that out, then you see our values for June 1st, June 2nd, June 3rd, June 4th, June 5th. Seems to be okay. And yeah, this is also something that's a little bit annoying with Python, that this last value is not included in the range, because normally you specify, if you put the number that you want to start with, why is the number you list at the end not included? That's just the way it is in Python. I could kind of go into a discussion about where that comes from, but it's not really so important as just recognizing that when you put this last value in there, it is going to be 1 less than that last value that gets included in what gets returned. So yeah, we've got the first column, top 5 rows, not bad. In fact, we don't even need to include the 0 here, because if you're going to list a range that starts at 0, NumPy will assume that value for you. And so you can do things like print out data. Again, we'll put our square brackets. But instead of doing 0, 5, you can just do 5, 0. So this, with nothing on the left side, we'll just assume it's going to start at the first index. In this case, index 0. And it still will end at index 5, but not include it, and give us the first column. And sure enough, we get the same thing out that we saw before. This is important because there are ways, like if you want to get all of the rows, you can actually delete that second number, and it will start from whatever the first index is and go all the way to the last index. And it will then give back all of the rows in the first column. So if you want to do that, you can see that's how it works. We're going to use this a lot. This kind of thing where you have some data file that's 2-dimensional. You want to get all the values from a single column out. We'll do this frequently, where you'll just take everything from the rows in the first column, second column, third column, whatever. In fact, we're going to do that. We'll do that right now, and I think, let me see how much we've got to cover. I think we'll get through this stuff, and then we'll take a a break here coming up shortly just to make sure I don't overload you with NumPy. So, yeah, you might remember that when we looked at this data file, we had these different column names in there, year, mota, temp, max, min. And now what we're going to do is take our data and put the different columns into different variable names so that they're easier to work with. So for instance, if we took date, let's make a new variable called date. And we'll set date equal to data. And we remember that the first column of data we have is where we have the date stored. So we can take an index slice for all of the rows in the first column. And we're going to store this in a variable called date. And that's more or less like similar kind of concept to what we just looked at. And if we print out then what is in date, we get back what we would expect, the values for the different days in June of 2016 with the notation that's used in this particular data file. You'll see different variations of how dates are dealt with in data files, but this is a pretty common one. Start with the year, then the month, then the day. It's nice because everything then sorts in order chronologically, so that's kind of handy when you sort the numbers. Okay, if you look down at the cells beneath here, all I've done is just left this stuff in here that will do the same thing for the other columns of the data file. So you don't have to type it in. You can just run this cell. But what we're going to do is we're going to put the stuff from column 2, the temperature values, into a variable called temp. Column 3, the temp max, into a variable called temp max. And then correspondingly, column 4 goes into temp min for the minimum temperature values. Does that make sense? Yeah? I didn't include any poll questions in this because like the other group is also using the polls and we have the same website. I didn't want to have like conflicting battles over who can use the poll. Anyway, all we're doing is we're just taking this two-dimensional thing, this data file, and just chopping it up into individual columns with different names. It makes it a lot easier to refer to individual variables or something like if we want to know just about the temperature, rather than taking data : comma 1, we can just put temp. It just makes it easier for us to handle. Something we haven't dealt with yet, and I don't know why we haven't dealt with it yet, is there is a magic command in Jupyter Notebooks or in IPython called whos. So if you start it with a %, this is how you indicate some magic command in the IPython Jupyter Notebook world. And whos is kind of nice because if you run that, it will tell you all the variables that are defined in memory. It will tell you their names, their data types, how big they are. So if you've been chugging through doing stuff in your Jupyter Notebook and you're like, I don't remember what's in data or how big it is or what happened to this or why is this giving me an error when I'm trying to access information from some variable, you can run whos and see right away, for instance, date is a type ND array, and it has 30 values in it, 30 elements, and it even tells you the type of data that's in there and how much memory is used to store that. The latter thing is probably not of so much concern, but this shows us that we've taken our data file that was originally 30 rows by 4 columns, and now we've chopped it up into 4 separate variables: date, temp, temp max, and temp min. Each one has 30 rows, and they're only 1 column wide. That's pretty much what we would have expected. So once we've done this, we can do some, I don't know if I would call it fun things, but interesting things. Like if we want to figure out what's the mean temperature in June of 2016, we have an easy way to do that. If we print out temp, that was our whole column of temperature values, temp.mean, and you have to include a pair of parentheses after this because this is something that's not known by NumPy when the data is put into this, but has to be calculated. If you print out temp.mean, what that does is it will calculate the mean value for this NumPy array called temp. And so we get back here, in this case, 59.73. if you're thinking this is temperatures and it's Helsinki, how is it possibly this hot? These are temperatures in Fahrenheit. So this is from a US government database that I pulled the data from. So it is local data, but it's been converted to Fahrenheit because that's how we do it. So we'll put this into something more familiar soon. Yeah. Anyway, the data that's in this database, everything is temperatures in Fahrenheit. So that's what we have here. And this is nice. Like this is a built-in method called .mean that gives us the mean value. If we wanted to find the min, the max, the standard deviation, we have built-in methods to do all that stuff easily. So you don't have to go and like write your own standard deviation function. We will end up doing that later in the course just so that you know how it's calculated, but these things are built into NumPy and they're pretty easy to use. So the last thing we'll do before we take a little break is just do a quick discussion of data type conversions. So when we looked at the data file that we started with, the first column of dates those weren't decimal values, those were just integer values. When you load them into NumPy, the default is to just convert everything to floating point numbers. But if we want to have those as just integer values, we can convert them back pretty easily. And the way we would do that is if we said date is equal to date, so same information we had before, but now we're going to add a method on here called asType. asType will convert whatever is here, whichever NumPy array you have, to be some other data type. In this case, it's an int that we want to convert it to an integer value, whole numbers. And if you run that date.asType int with int in quotation marks, you can print out date now. And what you should see when you print date is there's no longer the decimal values after that. These are just whole numbers like they were in the original data file. And if you want to even double check that, you can print out date.dtype. So that's the data type of the values that are stored in the NumPy array called date. If you print out date.dtype, you should get back that it's an int 64. So it's been converted to an integer value. A lot of times it won't necessarily matter if you're dealing with integers or floating point numbers, but there are some cases where you want to check and say, like, is the date exactly equal to this number? And when you compare things, like if you want to say, well, let's just add one cell here just to do a test. So if we say 5 equals 5 in Python, that's a way of doing a logical comparison to say, like, is this value equal to another value? And if you run that, you get back true. That's not a big surprise. But let's say 5 equals 5.0 probably will still get true. So that's, yeah, not such a big deal either. But there are cases where, like, because of the rounding, you'll end up with some number that is represented in Python not as 5.0, but as like 5.0000000000001. And if you compare that to the integer value number 5, it will say that they're not equal to one another, even though to 16 decimal places they're the same number. So there are times when you want to do things like convert to integers to make sure you don't have issues with this decimal place and then a whole bunch of zeros and a 1, or .999999999. Sometimes when you do decimal math in Python, you get numbers that are very close to what you expect, but not exactly. So, yeah.
Yeah, I'm just wondering, why is there, like, when you do the date conversion to the integer value, why it has to be in the quotation marks?
The int.
Yeah. It is a type of variable and not a string. So that's what like, it's kind of counterintuitive.
Yeah, I don't actually know that it does need to be in quotation marks. In fact, it will work for some data types without being in quotation marks if it's a built-in data type in Python. But there are some NumPy versions, like if you want to say like represent this as int 32, I think that will convert it to be a 32-bit integer, so storing it with kind of half as much memory footprint. That, I believe, has to be in quotation marks because it is a specific data type in NumPy. And yeah, if you try to run that without the quotation marks, it doesn't recognize it as a built-in data type in Python. So it will work for certain cases. But like for floating point numbers, there's a lot of different ways you can represent them in Python. Sometimes you want to save memory and make them small, so yeah, for NumPy there's many different options.
Yeah, actually that kind of is the like, or answer the question is like, because it's specific to the NumPy, so that's why it has to be in quotation.
I think that's right.
Like normally Python doesn't read it if it's like different from, if it's not specific.
Yeah. Yeah, so I think what happens here is it looks up in some table how to convert that based on the string, and yeah, so anyway, are there any questions about this stuff so far? I know the introduction to NumPy is not necessarily the most exciting topic, but this is kind of our gateway to being able to load in data files and start to do more interesting stuff. So yeah, are there questions? If not, why don't we let's go for 15 minutes. We'll give you a proper break, and we'll continue then at 10:40.